Today I am going to start a new chapter. Chapter is the solid state. It is the unit number 1 from part 1 book. So in this chapter we will discuss about the structure of solid, how different type of particles in a solid are arranged in a solid. We will discuss in this chapter. So solids are made up by either atoms or molecules or ions. So in a solid, in a particular type of solid, how different type of particles are arranged, we will discuss in this chapter. So in a solid, some solids are containing atoms, some solids are containing molecules, some solids are containing ions. So atoms and molecules and ions in a solid are known as constituent particle of a solid. So in a particular solid, constituent particles are arranged in which order? How constituent particles are arranged in a solid? On the basis of it, solids are broadly classified into two types: crystalline solid and amorphous solid. So solids are broadly classified into how many types? Two types: crystalline and amorphous solid. This is the classification of solid on the basis of arrangement of the constituent particles in a solid. So on the basis of arrangement of constituent particles in a solid, solids are classified into how many types? Two types: crystalline solid and amorphous solid. So what are the basic differences between the crystalline and amorphous solid? So basic differences between the crystalline and amorphous solids are: in a crystalline solid, constituent particles have long range order of arrangement. Long range order of arrangement means regular arrangement, means arrangement of the constituent particles in entire the solid is similar. At the different part of the solid जब constituent particle लोगों का arrangement same होता है, that type of arrangement is called long range order of arrangement or regular arrangement. So in a crystalline solid, constituent particles have long range order of arrangement. But in an amorphous solid, constituent particles have short range order of arrangement. That means at the different part of the solid, arrangement of the constituent particles are different. So regarding long range order of arrangement and short range order of arrangement shown in a figure, these two type of arrangement shown in a figure number 1.1 from your textbook. So another point of difference between a crystalline and amorphous solid is crystalline solids have sharp melting point. Sharp melting point means crystalline solids are converted into liquid state at a particular melting point. So melting point is a temperature at which a solid starts to convert into liquid state. So crystalline solid का particular एक melting point होता है. crystalline solid लोगों ने crystalline solids particular एक temperature में liquid state में convert होता है. But amorphous solids, they don't have a particular melting point. They are converted into liquid state at a range of temperature. Range of temperature means suppose one amorphous solid is converted into liquid state in between 120 degrees Celsius to 150 degrees Celsius. So amorphous solids, they don't have a particular melting point. They have a range of temperature at which they are converted into the liquid state. And another important point of difference between the crystalline and amorphous solid is crystalline solids are anisotropic in nature. Anisotropic means in the same solid in the same solid in the different direction when values of some physical properties are different, that property is called anisotropic property. जब सेम सॉलिड में डिफरेंट डायरेक्शंस में फिजिकल प्रॉपर्टीज का वैल्यू डिफरेंट होने से that type of property is called anisotropic property. So crystalline solids are anisotropic. That means same solid में different directions में physical properties का some physical property का value क्या होगा, different होगा. लेकिन amorphous solids are isotropic. मतलब same solid में different directions में physical properties का value क्या है, same. जब सेम सॉलिड में डिफरेंट डायरेक्शंस में फिजिकल प्रॉपर्टीज का वैल्यू सेम होने से आइसोट्रोपिक, जब सेम सॉलिड में डिफरेंट डायरेक्शंस में फिजिकल प्रॉपर्टीज का वैल्यू डिफरेंट होने से दैट इज कॉल्ड एन आइसोट्रोपिक. सो अनदर वन डिफरेंस बिटवीन द क्रिस्टलाइन एंड एमोर्फस सॉलिड इज crystalline solids are called true solid, but amorphous solids are known as pseudo solids or super cooled liquid. So amorphous solids are also known as pseudo solids or super cooled liquid. So why they are also known as pseudo solid or super cooled liquid? Because amorphous solids have tendency to flow, though very slowly. So amorphous solid flow करता है लेकिन लिक्विड जैसा फ्लो नहीं होता है. इन लोगों का फ्लो को हम लोगों को दिखाई नहीं देता है. So why amorphous solids are also called pseudo solid or super cooled liquid? Because they have tendency to flow, though very slowly. So amorphous solids have tendency to flow, लेकिन flow is very slow. जैसे कि ओल्ड बिल्डिंग में जो विंडो पेन्स लगाया जाता है, ग्लास विंडो में जो ग्लास पेन लगाया जाता है ओल्ड बिल्डिंग में, जब ये जो ओल्ड बिल्डिंग का विंडो में जो ग्लास पेन होता है, ग्लास पेन लोगों का थिकनेस मेजर करने से हम लोगों को क्या दिखाई देगा, ग्लास का अपर पार्ट में, अपर एरियाज में, अपर पार्ट में विंडो पेन का थिकनेस कमती होगा लेकिन लोअर पार्ट में थिकनेस ज़्यादा होगा. तो जब ग्लास पेन को विंडो में जब लगाया था तो ग्लास पेन का थिकनेस इक्वल था, लेकिन जब आफ्टर 20-30 ईयर्स हम लोग विंडो पेन को मेजर करने से क्या दिखाई देगा, अपर पार्ट में थिकनेस कमती हो जाएगा, लोअर पार्ट में थिकनेस बढ़ जाएगा. तो क्यों अपर पार्ट में थिकनेस कमती हुआ, लोअर पार्ट में थिकनेस बढ़ा? क्योंकि ग्लास पार्टिकल फ्लो किया, ऊपर से नीचे फ्लो हुआ ग्लास पार्टिकल लोगों का, लेकिन फ्लो इज वेरी स्लो. सो ग्लास इज एन एग्जाम्पल ऑफ एमोर्फस सॉलिड. तो ग्लास कैन फ्लो, ग्लास पार्टिकल्स कैन फ्लो, लेकिन फ्लो को हम लोगों को दिखाई नहीं देता है, लेकिन फ्लो को हम लोग ग्लास पेन को मेजर करके ऑब्जर्व कर सकता है. Therefore, amorphous solids are also called pseudo solid or super cooled liquid because they have tendency to flow though very slowly. So these are the very basic differences between the crystalline and amorphous solid. So on the basis of what type of constituent particles are present in a crystalline solid, on the basis of it, crystalline solid again classified into 4 different types: molecular solids, ionic solids, metallic solids, covalent or networking solids. So this is the classification of solid on the classification of crystalline solid on the basis of what type of constituent particles are present in a solid. There are 3 types of constituent particles are present in a solid: atoms, molecules or ions. Some solids are containing atoms, some solids are containing molecules, some solids are containing ions. So on the basis of constituent particles, what type of constituent particles are present in a crystalline solid, on the basis of it, crystalline solids are classified into then how many types? 4 different types. From your textbook, in table number 1.2 regarding the different types of crystalline solid discussed in this table. So first type of crystalline solid is molecular solids. So in molecular solids, constituent particles are molecules. The molecular solids are made up by molecules. So in a molecular solid, molecule to molecules, intermolecular forces of attractions are present. So in a molecular solid, molecule to molecule, what type of intermolecular forces of attractions are present? On the basis of it, molecular solids again classified into how many types? 3 types. Non-polar molecular solid, polar molecular solid, and hydrogen bonded molecular solid. So in a molecular solid, constituent particles are molecules. Molecular solid again classified into 3 different types. So molecular solid again classified into 3 different types on the basis of nature of intermolecular forces between the molecules. जब molecule to molecule weakest dispersion or London forces होता है, that type of molecular solid is called non-polar molecular solid. तो non-polar molecular solid में molecule to molecule dispersion और London forces होता है. For example, argon, carbon tetrachloride, hydrogen H2, I2, CO2. Normally non-polar molecular solid में non-polar molecular solid को normally gaseous state में मिलता है, क्योंकि gaseous state में ही molecule to molecule सबसे weakest dispersion और London forces होता है. और these are physical nature, soft, electrical conductivity, they don't conduct electricity, so they are called insulator, or melting point is very low. In polar molecular solid, molecules are held together by the dipole-dipole interactions or dipole-dipole forces. Dipole-dipole forces means this is the forces of interaction between the two polar molecule. For example, HCl. In HCl molecule, in HCl, between the HCl molecules, dipole-dipole interaction or forces are present. Sulfur dioxide. These are also soft and electrical insulator. They don't conduct electricity, and melting point low. Another type of molecular solid is hydrogen bonded molecular solid. In the hydrogen bonded molecular solid, molecules are held together by the hydrogen bonding. The hydrogen bonding, it is the intermolecular forces of attraction. It is relatively strong intermolecular forces of attraction between the hydrogen atom of one molecule and highly electronegative element of the another molecule. जैसे कि water in solid state is called ice. So water molecules are associated by the intermolecular hydrogen bonding. Therefore, water is a hydrogen bonded molecular solid. So due to the presence of strong intermolecular forces, hydrogen bond is a strong intermolecular forces. So hydrogen bonded molecular solids are hard. These are also electrical insulator, and melting point is low. So after molecular solid, second type of crystalline solid is ionic solids. So in ionic solids, constituent particles are the ions. Cations and anions are the constituent particles of ionic solids. So in an ionic solid, cation and anions are held by the strong electrostatic or coulombic forces of attraction. Electrostatic or coulombic forces of attraction, which is also known as ionic bonding. So in an ionic solid, oppositely charged ions are held together by the strong electrostatic or coulombic or ionic forces of attraction. So sodium chloride, magnesium oxide, zinc sulfide, calcium fluoride, so these are the example of ionic solid. So in sodium chloride, sodium and chloride ions are present. Magnesium oxide, magnesium ion and oxide ions are present. So due to the presence of strong forces of attraction between the oppositely charged ion, these are the hard and brittle, and these are insulator in solid state. आयनिक सॉलिड्स डू नॉट कंडक्ट इलेक्ट्रिसिटी इन द सॉलिड स्टेट. सॉलिड स्टेट में इन लोग इलेक्ट्रिसिटी कंडक्ट नहीं कर सकता है क्योंकि आयंस आर टाइटली हेल्ड इन द सॉलिड स्टेट, बट कंडक्ट्स इन मोल्टेन स्टेट एंड इन एक्वस सॉल्यूशन. मोल्टेन स्टेट मतलब सॉलिड सब्सटेंस का लिक्विड फॉर्म को मोल्टेन स्टेट बोला जाता है. जब एक सॉलिड को हीट करके लिक्विड बना देता है, दैट इज कॉल्ड मोल्टेन स्टेट ऑफ द सॉलिड. सो आयोनिक सॉलिड इलेक्ट्रिसिटी कंडक्ट कर सकता है मोल्टेन स्टेट में, और आयोनिक सॉलिड का एक्वस सॉल्यूशन में भी आयोनिक सॉलिड इलेक्ट्रिसिटी कंडक्ट कर सकता है. तो क्यों मोल्टेन स्टेट और एक्वस सॉल्यूशन में आयोनिक सॉलिड इलेक्ट्रिसिटी कंडक्ट कर सकता है? क्योंकि इन मोल्टेन स्टेट और इन aqueous solution ions become free to move. So through the ionic solution, through the aqueous solution of the ionic solid, ions are conducting the electricity क्योंकि ions become free to move. So they have high melting point because in ionic solid oppositely charged ions are held together by the strong ionic bonding. So these are the hard, therefore they have high melting point. So third type of crystalline solid is metallic solid. In metallic solid, metal ions are present. Metallic solid में positively charged metal ions are present. In an ionic solid, positively charged metal ions are immersed or delocalized in the sea of electron. sea of electron. तो मेटेलिक सॉलिड में क्या होता है, इलेक्ट्रॉन का सी होता है, सी. तो मेटेलिक सॉलिड में इलेक्ट्रॉन्स का सी होता है जहां पॉजिटिवली चार्ज मेटल आयंस लोग इमर्स्ड होता है. सो इन ए मेटेलिक सॉलिड, मेटल टू मेटल स्ट्रॉन्ग मेटेलिक बॉन्डिंग इज प्रेजेंट. तो आयरन, कॉपर, सिल्वर, मैग्नीशियम, these are example of metallic solid. So metallic solid, in metallic solid, due to the presence of strong metallic bonding between the metal atoms, they are hard but malleable and ductile. Malleable मतलब हीट करने से उन लोग सॉफ्ट हो जाता है. डक्टाइल मतलब इन लोगों को पीट के लंबा वायर बना सकता है, सीट बना सकता है, इसलिए these are called ductile. So metallic solids are hard, malleable and ductile. So metallic solids are conduct electricity in the solid state as well as in the molten state. तो metallic solid electricity भी conduct कर सकता है, heat भी conduct कर सकता है, both in molten state, both in solid state and in molten state. So why metallic solids are good conductor of electricity? क्योंकि metallic solids are containing free electron. So through the metallic solid, free electrons are conducting electricity. So metallic solids have fairly high melting points. So in a metallic solid, metal ions are associated or held together by the metallic bonding. So due to the presence of strong metallic bonding, metallic solids are hard and they are malleable and ductile. So metallic solids are conductor of electricity both in solid and in molten state. Why metallic solids are good conductor of electricity? Due to the presence of free electrons in them. So third type of molecular solid is covalent or networking solid. Covalent or networking solid. So in a covalent or networking solid, atoms are the constituent particles. Neutral atoms are the constituent particle of covalent or networking solid. Normally these are the non-metal atoms. So covalent solids are made up by non-metal atoms. So in a covalent solid, non-metal to non-metal, strong and directional कोवेलेंट बोन्स आर प्रेजेंट. कोवेलेंट बोन को डायरेक्शनल बोन बोला जाता है क्योंकि कोवेलेंट बोन फॉर्म होता है एट ए पर्टिकुलर डायरेक्शन. सो इन कोवेलेंट सॉलिड, नॉन मेटल एटम्स आर हेल्ड टुगेदर बाय द कोवेलेंट bonding. For example, silica, SiO2, this is also known as quartz, silicon carbide, carbon, diamond aluminum nitride, graphite. These are example of covalent solid. Or covalent solids are hard. Why? Because in a covalent solid, strong and directional covalent bonds are present. Or covalent solids are also known as giant molecule, G-A-I-N-T. Covalent solids are also known as giant molecule. And these are covalent solids are also hard, and these are insulator, and melting point is very high. So why melting point of covalent solids are very high? Due to the presence of strong and directional metallic bonding between the non-metal atoms in a covalent solid. So silicon dioxide, silicon carbide, carbon का दो फॉर्म है, diamond and graphite, carbon diamond, these are hard. Graphite also an example of covalent solid, but graphite is soft and it is conductor of electricity. देखो covalent solid क्या होता है? hard होता है, electrical insulator होता है, they do not conduct electricity, लेकिन it is exceptional in case of graphite. Graphite is a covalent solid. Graphite covalent solid होने से भी ये क्या है? soft and conductor होता है. So why graphite is soft and conductor? Normally covalent solids are hard and electrical insulator, they do not conduct electricity, लेकिन it is exceptional in case of graphite. So graphite is soft and graphite is conductor of electricity. So why? So this is the structural difference between the diamond and graphite. Now, diamond and graphite are the two allotropic forms of carbon. So diamond is hard but graphite is soft. So why? This is due to the structural difference between these two substances. So this is the structural difference between the diamond and graphite. This is the structure of diamond, this is the structure of graphite. In diamond, what happened? In diamond, one carbon atom is bonded to 4 other carbon atoms. In diamond, all the carbon atoms are sp3 hybridized. In diamond, around a particular carbon, all the 4 covalent bonds are directed along the corner of a tetrahedral. और कार्बन का 4 वैलेंस इलेक्ट्रॉन होता है, all the 4 valence electrons are participating in the bond formation in diamond. All the 4 valence electron of carbon are sharing to form 4 covalent bonds. So diamond में free electron नहीं है, क्योंकि कार्बन का सभी वैलेंस इलेक्ट्रॉन bond formation में sharing हो रहा है. So due to the absence of free electron, diamond is electrical insulator. And diamond has 3-dimensional networking structure. This is called 3-dimensional networking structure. Therefore, diamond is hard. So diamond is hard due to its 3-dimensional networking structure. And it is electrical insulator. Why? Due to the absence of free electrons in it. Or in a diamond, carbon-carbon bond distance is equal to the single bond, carbon-carbon single bond distance, that is 154 picometer. So why diamond is hard? Due to its 3-dimensional networking structure. And why it is electrical insulator? Due to the absence of free electrons in it. But graphite, it has layer structure. Graphite, this is the layer structure of graphite. So one layer to another layer, there is no pure covalent bond. One layer to another layer, there is a van der Waals forces of attraction. There is a van der Waals forces of attraction. So how many distance between the two layers? 340 picometer. So due to this layer structure, graphite is soft. So in a single layer, in a particular layer, one carbon atom is bonded to how many other carbon atoms? 3 carbon atoms. In graphite, one carbon atom is bonded to how many other carbon atoms? 3 carbon atoms. So in graphite, each carbon is using only 3 valence electron for bond formation out of 4. कार्बन का पास 4 वैलेंस इलेक्ट्रॉन है, लेकिन आउट ऑफ 4 वैलेंस इलेक्ट्रॉन ओनली 3 वैलेंस इलेक्ट्रॉन बॉन्ड फॉर्मेशन में पार्टिसिपेट करता है इन ग्रेफाइट। इसलिए ग्रेफाइट में कार्बन का पास जो 4th इलेक्ट्रॉन होता है, दैट 4th इलेक्ट्रॉन इज द प्रेजेंट एज ए फ्री इलेक्ट्रॉन्स, और ड्यू टू द प्रेजेंस ऑफ फ्री इलेक्ट्रॉन ग्रेफाइट इज द कंडक्टर ऑफ इलेक्ट्रिसिटी. So graphite is the conductor of electricity due to the presence of free electrons in it, and graphite is soft. Why? Due to its layer structure. So graphite is used as a solid lubricant. जिस मशीन में, जिस इंजन में लिक्विड लुब्रिकेंट यूज नहीं कर सकता है, in that engines, in that machines, graphite is used as a solid lubricant. So this is the structural difference between the diamond and graphite. So diamond is a covalent solid and graphite also covalent solid. So normally covalent solids are hard and electrical insulator, but graphite is electrical conductor and it is soft, although graphite is a covalent solid due to its structure. So this is about the introduction of this chapter. So in this chapter, then solids basically classified into how many types? 2 types, crystalline and amorphous solid. So solids are classified into 2 types broadly on the basis of arrangement of constituent particles in a solid. Again, crystalline solids are classified into how many types? 4 different types. So crystalline solids again classified into 4 different types on the basis of constituent particles in a crystalline solid. Thank you.